All right, record. Yeah, I think now it's recording. Okay, perfect. Thank you, Daniel. Yeah, so just I'm gonna just probably go up here. So just to show you that the exercise. So we have this log of x plus 1 plus log of x plus 2, which is equal to this log of x minus 2. Anyway, so we combine the first two logs on the left side in just one log, and then we move the log on the right side to the left side. Now we have the difference between two logs, and as I said, so the difference between two logs, that will be log of x over y. So this is log of x over y. So this is like my x, and this is like my y, right? So now it's log of x, which is the x minus 1 times the x plus 2, right? X minus 1 times x plus 2 over, right, over y, and y it's x minus 2, right, which is equal to 0. Right now I have just one log, right? So now I can move to the next step. So once we have just one log, we can you can move to the next step and get rid of the log.
Wait,
so
Professor,
yes,
wait, can you give me like 10 seconds?
Yeah, sure.
Thank
you. So in the next step number 2, we're gonna get rid of the log. And the way to get rid of the log is we need to use the following identity, right? So we need to use, if you have like log in base a of x equal y, right? Then this is equivalent to a to the power y equal to x, right? So that's a to the power y equal to x. So like, sorry, I forgot the base 4 here. So like in our example, a would be 4. So this is the 4, that's my base, that's a. The right side, you see the right side, that's my y. Okay, and what's inside the log, that's my x. So this whole thing here, inside the log, this whole thing here, that's like my x. Okay, so this is like log in base a, which is 4, of this whole thing, x minus 1, times x plus 2 over x minus 2, right? That's like my x. And then on the right side, that's y, which is 0. So then that will be a. So if we apply our identity, right? So that's a. A is 4 to the power y. So just be careful, guys. So it's not y to the power a. It's a to the power y. It's the base. The base is the a, right? So exponential in the base a, which is 4 to the power y. Y is 0, right? Equal to x. X, that will be the thing inside the whole expression inside the log. So that's like, x minus 1 times x plus 2 over the x minus 2. Right, so just be careful here. This is not, so this is a to the y, not y to the a. So this is a to the y, not y to the a, because this is kind of like a common mistake, But anyway, so 4 to the power 0, I mean, any non-zero number to the power 0 is just 1. This is just equal to 1, this thing here. Right, so what we have is the following. So we have like, x minus 1, times x plus 2 over x minus 2 equals to 1. Right, that's a 4 to the power 0. All right, so first, so we have like an equation between two fractions. I mean, the right side, again, doesn't look like a fraction. The right side, it's a whole number, which is 1, but it's still, you can, if you divide 1 by 1, which is still 1, of course, you make it look like a fraction. So then, and then you can just, cross multiply. So here we can cross multiply. And so what we have is x minus 1 times x plus 2, times, that's supposed to be times 1, right? And then on the other side, we have like x minus 2 times 1. But anyway, so when you multiply anything by 1, you're going to get the same thing. So it doesn't change your expression, right? So this x minus 1 times x plus 2 times 1, it's just x minus 1 times x plus 2. The same on the right side. All right, so now what we can do is we can, as you can see, the left side looks like a quadratic function, because the highest power of x on the left side is x squared, right? Because you multiply x by x, as you can see here, x by x, that will be x squared. So if you distribute, so we're gonna have x times x, that's x squared, and then x times 2, that's 2x, and then there's 1, it's 1 times x, and don't forget there's a minus, so that's minus 1 times x, so that's minus x, right? And then minus 1 times 2, that's minus 2. Right, that's the left side, and the right side is just x minus 2. All right, so let's just simplify this thing. So this is x squared, and this is 2x minus x, so that's just 1x plus 1x, and then minus 2 equal to x minus 2. Right, and then you can you can simplify your equation. You can, there's an x on the right side, right? There's this x on the right side, and there are, of course, x's on the left. So we're going to move all the x's on the same side, on the left, let's say. So I'm going to subtract here minus x, right? Just to get rid of this x, and do the same on the left. Okay. So if you do that, then it's now x squared, and as you can see, the x cancel out. I mean, x minus x, it just cancel out here, and then it's just x squared minus 2 equal to minus 2. All right, and now I mean, you have only x squared, right? You don't have like x squared and x. It's just x squared. So if you add, let's say, plus 2 both sides, now it's x squared equals to, minus 2 plus 2 will be 0. Same here, minus 2 plus 2 will be 0. So it's just x squared equal to 0. And x squared equal to 0. You can apply the square root to get rid of the square. You have your square equal to 0. So I'm going to apply the square root. Here's my square root. Here's my square root. And don't forget, because it's the power of x is even, you have the even power, you're supposed to have plus or minus. Right? Whenever you have even power, nth root, then you need a plus or minus. But anyway, here it doesn't make any difference, because plus or minus 0 is just 0, right? So this is, this is just a plus or minus, and square root of 0, because 0 times 0 is 0, so it's just 0. And plus or minus 0, of course, is just 0. So the solution is just x equal to 0. Okay, but this is a possible solution. We are not done. Don't forget, there is the last step where you have to check if your solution is a true solution, because whatever you have inside the log, it must be positive, right? So this is just a possible solution. And we're gonna check in the last step, step number 3. We need to check if x equal to 0 is a true solution to the problem. Okay. So what's the problem? The equation? Well, you know, the original. Let's come back to the original equation. So we had. So let me just write it down here again. So the original or the initial, the original equation is, you know, we had like log n base 4 of x minus 1 plus log n base 4 of x plus 2 equals to log n base 4 in x minus of x minus 2. Right, this is my original, my initial equation. Now, as I said, whatever you have inside the log, it must be positive. Otherwise, it's not, it's undefined, right? So the x minus 1 must be positive, the x plus 2 must be positive, and the x minus 2, the x plus 2 must be positive, and the x minus 2 must be positive, right? So the x, so the x minus 1 and the x plus 2 and x minus 2, they must be positive, because that's the definition of a log. Wherever you have inside the log of -3 doesn't exist. It's undefined, right? So log of negative numbers, and actually even log of 0, it's undefined. It must be positive. Must be positive. So, okay. Now, our solution is x equal to 0. So if my x is 0, the question is x minus 1 positive if x is 0? Well, if x is 0, then 0 minus 1 would be -1. That's not positive, right? It's negative, right? So then we have to reject this solution, x equal to 0. So if x is 0, then if you evaluate x minus 1, so that's like 0 minus 1, right? If your x is 0, so that's 0 minus 1, which is -1. And this is negative, right? So it's not positive, right? So we have to reject this solution. So x equal to 0 is rejected.
I have a question.
Yes, please.
Can inside the log be equal to 1, or it can't be equal to 1?
No, inside the log it can be equal to 1, of course. Log of 1 is always 0, actually.
Right.
Log of 1 in any base. In any base, this is equal to 0. Yeah, it can be equal. Yeah, can be 1. That's because, you know, a to the power y, so a to the power 0 is 1. It's x, right? This is so this is a, this is like x, and this is like y, right? So a to the y is x, so a to the 0 is 1. Any other question, guys? So the final answer, your final answer should be, and as I said, in the test, for sure, you're gonna have to solve some logarithmic equations, right? So in the test, if you don't check if your solution is a true solution, you won't get full credits, okay? Because you know, it's just like by definition of a log, you need everything inside the log to be positive. So yeah, so final answer, your final answer should be, so there is no solution to this problem. There is no solution. Right?
Excuse me, Professor.
Yeah, Christina. Yeah, go ahead.
So we happen to get the answer of 0, right?
Mhm.
Here. But as it was like a quadratic, we would usually get 2 answers.
Yep.
So we're checking both answers, and we
Yep.
could always reject one,
Yeah, of course.
but
You can
then
reject-
we would still have one that's
it's a true
a
solution. Yeah.
solution.
Yeah, I mean, you can reject one, or you can also reject both, the two solutions. I mean, of course, depends on the, depends on the equation. So, yeah, of course. That's true. I mean, here, well, it's just a coincidence. I end up with one solution, but because, as you said, because it's quadratic, you're supposed to have, like, in general, you're supposed to have like 2 different solutions. And then, yeah, you have to check both of them. Yep. Any other questions, guys? All right. Okay, so that's for chapter 3. I mean, I think we did everything here. I mean, we solved different kind of equations, exponential, log, and that's that's good, actually. All right, so I guess we can move to the last chapter, chapter 4, which is trig. And I know trig is, it's kind of, it's not easy. Sometimes it's confusing, and the problem is, like, we don't really have time, to cover everything in chapter 4. We have like 1 lecture and a half left. So anyway, I'm gonna try to do my best, and then we'll see. Yeah, so let's move to the chapter 4. And again, this is not included in the second test. So this is not in the second test, not in the test number 2. But of course, it's going to be in the final. Okay, not in the second test. All right. So let's start with the section. I'm going to try to combine actually sections 4.1, 4.2, and 4.4. They are very similar sections. Anyway, so I'm gonna first introduce what's an angle, right? And then we're gonna measure angles, using radians, degrees, etc. And we see how to convert, radian to degrees, and degrees to radians, etc. And then, of course, I'm gonna introduce trig functions, and yeah, and of course, the goal would be to solve some trig equations, but I don't know if we're gonna have time, actually, to solve some trig equations. Anyway, let's see. So let me start with the definition of an angle, right? What's an angle? Well, an angle is formed by 2 rays that have a common vertex. So an angle is formed by 2 rays, okay, that have a common vertex. Okay, so it's like, so here's your vertex, right? And then this is my vertex, and then you have like an initial side, my first ray. So this is like my initial side, and then there is a terminal side. This is my terminal side, right? And so, you're supposed to go like from the initial side to the terminal side, and that will be your angle. So the angle, so your angle in this case would be, this one here. So this is your angle. You're supposed to go from the initial side to the terminal side. So this is your angle. Let's call this angle theta. Right. This is This is theta. Okay. Of course, theta, this is a Greek, it's a Greek letter, guys, right? It's like, you know, we are using Greek letters for everything, right? Like for COVID or, you know, but anyway, so yeah, this is my angle theta. And there are actually two possible rotations, right? Because so there are two possible rotations. So there is a counterclockwise rotation and there's a clockwise rotation. So there's so the first possible rotation is, you know, you have your vertex. This is your vertex, and then let's say this is your initial side, and here's your terminal side. Right, this is your terminal side. Terminal side, initial side. So this is your angle theta. Okay, so so this is, of course, this is a counterclockwise. This is a counterclockwise rotation, right? This is counterclockwise rotation. Now, if you switch the terminal and initial side, so if you have again, this is vertex. Now let's say this is my initial side, and here's my terminal side. So if you go from initial side to the terminal side, you get your angle theta, and in this case you have a clockwise rotation, right? It's this is theta, the angle theta. And so in this case, we have a clockwise. It's a clockwise rotation. Right. So by convention, guys, if you have a counterclockwise rotation, then you get positive. So a positive angle. So this is a positive angle. So whenever you have a counterclockwise rotation, that's a positive angle. And when you have actually clockwise rotation, that's actually a negative angle. Okay. And that's because, you know, when you, the thing is, you know, when you have like your x-axis and then you have like your y-axis, and you're supposed to, you know, the first axis is supposed to be the x-axis and the second axis is the y-axis. So if you go from x to y, so this is like the positive, that's like the positive. It's just a convention, right? But that's like the positive rotation or positive angle. Okay. But anyway, yeah, but you need to keep in mind, so an angle can be positive or it can be negative. So it's just some number. You know, we're gonna measure now the angles, of course, but it's gonna be a number which you know, can be positive or negative. Now let's measure some angles. Okay, so I'm gonna measure now. Measuring angles. Okay, so the units we use to measure angles, of course, are two different units. There are the degrees and the radians. So we use degrees or radians to measure angles. Okay. So what's the relation between degrees and radians? So for example, I'm gonna just first give you an example, and then I'm gonna and we're going to explain the relation between the two units. So example, let's have like a right angle, right? So this is so this is a right angle, and so the angle theta is this one here, and it's, so this is your theta, and so this is, again, this is, let's say, initial side, and here's your terminal side. So for example, for right angles, terminal, sorry. So you know, like for right angles, the angle theta is 90 degrees, right? So right angle. So right angle would be a 90 degrees, right? So this is a symbol for degrees, right? And now if you use the radians, so that will be pi over 2. Okay, so pi, it's just you know, it's a decimal. It's actually you know, we use the pi to measure, you know, the boundary of the circle, for example. And the pi is just a decimal number, which is actually approximately, you know, 3.1415, etc. Right? But anyway, so the idea is that 360 degrees, or let's say not 360, but let's say 180 degrees, that's equal to pi, right? So so if you want to convert, so if you want to convert, let's say degrees to radians, okay, then you need to, so we need to multiply so we multiply by, you know, pi over 180. So for example, let's say you have like 90 degrees. Example 1, you have 90 degrees, okay, which is a right angle, and you want to convert. So here I'm trying to convert degrees to radians. So if you want to convert 90 degrees to radians, so as I said, we need to multiply by, you know, pi over 180. So this is 90 degrees times pi over 180, right? And of course, I mean, you can reduce, I mean, 90 over 180. I mean, you can divide here by 90, of course, and here by 90. So that's just pi over 2. Okay, 90 over 180, that's half. So then the answer is a half of pi, right? Let's take another angle. If you have like 60 degrees, right, and you want to convert this to radians, So 60 times, as I said, pi over 180. So then 60 over, 180. You divide by 60. I mean, 60 and of course, 60 and 180 both are divisible by 60, right? And 60 is just 1/3 of 180, right? So that's pi over 3. Okay, etc. Yeah.
Why don't you just show us that 60 pi over 180 and then divide by 60? It makes it more simple.
Yeah, it's absolutely, yeah. It's I probably jumped one step here. Yeah, you're probably right. Yeah, of course. So yeah, it's just the same thing. Yeah. Well, sorry. Yeah, you can say, well, this is. Oops. So this is 60. I guess you mean 60 times pi over 180, right? And then, yeah, so then you reduce your fraction, as you said. So you, divide this is by, 60 over 180. So that's, divide by 60, right? So that's pi over 3. It's the same thing, right? Because, this 60 here, this is, you can think of this 60 as a fraction if you divide by 1. So this is like 60 over 1, right? So like you have your 60 in the top and your 180 in the denominator. So it's just the same thing. Yeah. Another example. So we have 60. If you have, let's say, 30 degrees. So that's like 30 times pi over 180 degrees. So it's 30 over times pi over 180, and then 30 over 180. Of course, I mean, you can divide by 30. I mean, 180 is divisible by 30. 180 over 30 is it's 6, right? This is over 30, so it's just pi over 6. Right, etc. So that's how we convert degrees to radians. Just multiply by pi over 180, because pi is supposed to be equal to 180. So when you multiply by pi over 180, it's like multiplying by 1. It didn't really change your angle. Now the other way, if you want to go from radians to degrees, so conversion. So if you want to convert from radians to degrees, then we multiply by 180 over. Multiply by 180 over pi. Okay. So yeah. So for example, let's say I want to convert, let's say 3 pi over 2. So 3 pi over 2, this is in radians, and you want to convert this. So convert to degrees. Okay. So all we need to do is to multiply by, as I said, by 180 over pi, right? And so here we can cancel out the pi. It's you have a multiplication in the top and multiplication in the denominator. So you can just you can cancel out the pi here, right? And then 180. So that's like 3 times 180 over 2. So this is like 180 over 2. That's 90, right? And 90 times 3. That's 270. So the answer This is 270 degrees. Right? Or, I mean, of course, you can say 180 times 3, right? 180 times 3 is 540 times 2, that's 270. Right? So, I mean, it's up to you guys. The way to, simplify your expression, it's, of course, it's up to you. I mean, one more example. Number 2, let's say you have like 5 pi over 6. Right, so you want to convert this to degrees. So 5 pi over 6, and then you multiply by 180 over pi. Right. So pi over pi cancel out. Now 180 over 6, right? 180 is the top, 6 is in the denominator. So 180 over 6, that's 30. Right, so it's just a 5 times 30. Right, this is, you can divide by 6 here, divide by 6 here. So it's just 5 times 30, which is 150 degrees. Okay, etc. Any question, guys? So to go from degrees to radians, you multiply by pi over 180. The pi is in the top. If you go from radians to degrees, it's 180 over pi. The pi would be in the denominator. All right, so here's an exercise for you guys. First, you need to convert. So please try to convert first to radians. This is exercise 1. So 2 radians. So here, let's say here's 210 degrees, right? And then you have one, let's say here, this is 120 degrees, right? Second exercise, 2. So let's convert now to degrees. Degrees. Okay, so let's say you have here it's 4 pi over 5. All right, and then 2 pi over 3. Right, I'll give you a couple of minutes to think about this. So yeah, you need to reduce your fraction, guys. When you convert, the goal is to reduce a fraction. It's just reducing fractions. Um, okay, Bayesian, you're saying 0.9 for number one. I don't know, what do you mean by 0.9? So you need to keep the pi. Don't replace pi by like 3.14 or anything, right? Just keep you need to keep the pi. So I think your answer number, so number 4, that's your answer. 120, that's correct, but the 0.9, the 1.5, so you don't like 1.5. You don't. Yeah. So that's the thing. Keep the pi. Don't replace pi by the 3.14, right? So like, like in my previous example, for example here, like for this 30 degrees, I kept the pi. Like in the answer, I kept the pi. I didn't divide like 3.14 by the 6, right? So just keep the pi. Okay. Okay. I see. Okay. Yeah, but it's better to keep the fraction. Don't once you reduce your fraction. So like, okay, so for like number 1, so to convert to radians, so we need to multiply by so here we need to multiply by pi over 180 to go to radians. So like 210, so 210, times the pi over 180. So in other words, this is like 210 times pi over 180, right? So now the next thing is to reduce this fraction. So you just you keep the pi, don't touch the pi, and then there's this 210 over 180, right? So the question is, how can you reduce 210 over 180? So for example, you can say, well, 180 and 210 both are divisible by 30, right? 210 over 30 would be 7, 180 over 30 would be 6, right? So for example, so you can reduce You can say, well, this is divisible by, I can divide this by 30, and I can divide this by 30. Okay, so it's divisible by 30 because it's divisible by 30 because 21, 21 is divisible by 3, and 18 is divisible by 3. So that's why both of them are divisible by 30. So we can say, well, this is now equal to, this is now equal to, so if you divide by 30, 210 by 30, that's 7, right, times pi over 180 over 30, that's 6, right? So the final answer, so then 7 over 6, 7 over 6, you cannot reduce 7 over 6 because, the only common factor to 7 and 6 is 1. So then the answer is 7 pi over 6. So the answer is 7 pi over 6. Okay, so don't divide 7 by 6. Just keep the fraction 7 by 6. Okay, but I don't know how you got the 0.9. I guess yeah, I don't know how you got this 0.9 because 7 over 6 anyway, it's 1 point something, right? It's more than 1.
Professor, hold on, where you got the 7?
Yes. 7 because it's 210 over 30. We have 20, we have 210 over 180. So I said, well, 21 and 18, both are divisible by 3, right? 21 over 3 is 7, and 18 over 3 is 6, right? So both are divisible by 3. Now there's a 0 here. So then that makes them both divisible by 30. So I divided 210 by 30 and 180 by 30. So 210 over 30, that's 7. You see how I got the 7? So we need to reduce a fraction. Or you can say, probably this is better. 210 over 180, you can say, well, first, they are both divisible by 10, right? Because both they have the 0. Like a first digit, they have a 0, right? So that makes them both divisible by 10. So this is 21 now over 18. And then 21 and 18 both are divisible by 3. Right, so that's 7 over 6. Make sense?
Yeah.
Okay, so that's how I got the 7. So 210 over 180, you can divide first by 10, and then, well, then you can see that both are divisible by 3. So that's 7 pi over 6. So you keep the pi, don't divide the 7 by 6. So if you cannot reduce a fraction, then that will be your final answer. And then, so let me just erase this thing here. Kiana, you're saying your number 1 is 144. Yes, I think you're correct, Kiana. Yes. Yeah. So now for number 2, this is 120 times pi over 180. So again, I'm gonna just first I'm gonna divide by 10. Let's say I'm gonna divide by 10 because this is 0 and 0 in the first digit. So that means that both are divisible by 10. So I'm gonna divide the 180 and the 120 by 10. So that's now 120 over 10, that's 12 times pi, right? And 180 over 10, that's 18. Now, can we reduce the 12 over 18? 12 and 18, you can say they are both even numbers, right? So you can, you can divide by 2, and even better than 2, you can, 12 and 18, they are divisible by 3, and actually they're even divisible by 6, right? 12 over 6, that would be 2, and 18 over 6, that would be 3, right? So you can reduce this fraction, and you can divide actually the 12 and the 18 by 6. So that's 12 over 6, that's 2. So that's like 2 times pi. And the 18 over 6, that's 3. So that's 2 pi over 3. So that will be the answer. That's the final answer, because of course 2/3, that you cannot reduce 2/3. I mean, 2 and 3, they don't have like a common factor besides 1, right? So you cannot reduce the 2 over 3. Now for number 2, 4 pi over 5, right? So then we need to, to convert to degrees. So we need to multiply by 180 over pi. So here we need to multiply by 180 times 180 over pi.
I'm sorry, Professor, excuse me.
Yeah.
I don't
please.
mean to backtrack a little bit, but I got 4 pi over 3 for the last one you just did.
The 4 pi over 3 for the 120.
Yeah.
4 pi. How did you get the 4 pi? 4. How did you get the 4?
Well, I did the first
Divided-
I did by 10, right?
By 10. That's 12.
12 over 18.
Yes.
And then by
4
3.
by 3. Okay, so if you divide by, okay. So you divide by 3, that's 4 over, and then 18 over 3, that's 6. So that's 4 pi over 6, right? 18 over 3, that would be 6.
Oh shoot. Okay, so still.
Yeah, then you can continue.
Oh, and then reduce again. Okay,
yeah, you can
okay,
reduce
okay.
again,
All right,
by 2.
got you.
Both are,
Okay, thank you.
both are even numbers, yeah. So this 4 pi over 5. So yeah, we said we need to multiply by 180 over pi to convert to degrees. 180 over pi. So then, as you can see, there's a pi in the top, there's a pi in the denominator, so the pi cancel out. Okay, that's first thing. Second, now, I mean, again, you can say, well, I can multiply the 4 by 180 and then divide by 5. It's up to you, right? Or you can divide the 180. I mean, because 180 is divisible by 5. You can divide 180 by 5. Right, so that's, you can divide, for example, here, this 180 by 5. This is 5 by 5, right? 180 divided by 5, that would be equal to 16. Sorry, what I'm saying. 36. I said 16. 36. 180 by 5. 36, right? So that's like 4 times 36, right? And 4 times 36, that's 144 degrees. Okay. Or of course you can say, well, 4 times 180 over 5, you can multiply the 4 by 180. So 4 times 180, that will be equal to 720 over 5, and then you divide 720 over 5. We can use the calculator, right? But again, we are trying to avoid using calculators, right? So of course you can divide 720 over 5, and you're gonna get the same answer. Of course, that will be 144, right? Or you can just, you have 180. You have this 180 by 5, you can divide 180 by 5, right? As I said, that will be 36. And then there's this 4 left, so that's 4 times 36. Again, there are different ways, to answer this. So it's up to you guys. But it's better to avoid like getting like large numbers, right? Like 720, that'll be kind of large number, but it's up to you. So that's 144 for number 1. Number 2, so it's again 2 pi over 3, and we're gonna multiply by 180 over pi. whenever you want to convert degrees to radians, as you can see, the first thing you can do is to cancel out the pi. So the pi cancel out. Now, as I said, so you can say, well, this is, 2 times 180, that's 2 times 180 over 3, right? So you can say, well, that's like 2 times 180, that's 360 over 3. And then, you divide 360 by, by 3, that will be 1. What did I say wrong? Something wrong here? No, I'm not. That's correct. So yeah, 120, right? Degrees. Or you can say another way to solve this, or you can say, we have 2 times 180 over 3. So actually you can divide the 180 by 3, right? You can, if you want to avoid large numbers, we can just divide this 180 by 3, divide by 3. 180 by 3, that's 60. So it's just it's 2 times 60 over 1, which is just 120, right? Anyway, you're gonna get the same answer, of course. Right. Again, it's up to you guys. The way to reduce the fractions, you can go step by step, or you can multiply everything and then divide. Is there any question, guys? So that's how we convert, degrees to radians to degrees, right? Now, so if you have like a circle, so we have like a special, there's some special angles. So so if you you have you can divide your angle, let's say here. So let's say this is, let's say this is for example, this would be this is your initial side. Let's say this is my initial, this one here, this is the initial side. Okay, and so let's say you're gonna go from from this angle to this one. This would be, let's say, 30 degrees, and as I said, 30 degrees, that's pi, that's pi over 6. And then this angle right here, this would be, let's say, 60 degrees. 60 degrees, that's pi over 3, sorry, what I'm saying, yeah, pi over 3. All right, and then you have a right angle. This angle here, this is a right angle, of course, it's 90 degrees. That's pi over 2, etc. So you can do like the whole circle, like here. Then this angle right here, that's, let's say, 120 degrees. This is, let's say, 120 degrees, and then you have, this is 150 degrees, and then this one here, that will be 180, right, etc. For example, 120, we said 120 degrees, that's 2 pi over 3, etc. Right? Anyway, so that's how we convert angles to degrees, degrees to angles. So next, guys, so what I'm gonna do, I'm gonna introduce the trig functions. What's the sine of an angle? What's the cosine of an angle, etc. I'm gonna try to compute the cosine and sine of some special, like very special angles, right? And then I'm gonna study a little bit the properties of cosine and sine. So yeah, next, yeah, I'm gonna introduce. So what's sine of theta and cosine of theta? Right. So what I'm gonna do, guys, I'm gonna use like a unit circle. So we have a circle with the radius equal to 1. So here's so this is your x-axis. This is your y-axis. This is, let's say this is 1. This is 1. This is a -1 right here, and this is -1, right, etc. Now we have a unit circle. So we have this circle with the center equal to the origin. So we have this circle. Okay, and the center of this circle is, of course, the origin. Okay, so this is the unit circle because, you know, the radius of this, the radius of this circle, the distance from the origin to the, or the center of the circle to the, you know, to 1 here, this is just 1 unit. So that's why it's called the unit circle. So the radius, this is your radius, right? And so this is a unit circle because unit circle so that's a circle with radius equal to 1. Okay, it's just 1 unit of the radius. All right, so I'm gonna take a random angle theta in this circle. For example, I'm gonna take, so let's say this is my initial side. This one here, this is my initial side, right? And this is, let's say, my terminal side. Okay, terminal side. Right, and here's my angle. So my angle theta is this one here. And this is my angle theta. Okay. Now I'm gonna take a right triangle in this unit circle. So I'm gonna take this right triangle right here. So I'm gonna take. You see this side here? So this is, of course, this is a right angle. Okay. And you know, I'm gonna consider this triangle. Okay. So let me draw again the triangle. So we have, like, you know, you have this triangle with a right angle right here, and this is my angle theta. This is my angle theta. Okay. Just keep in mind, because this is, you know, this is a unit circle. So the radius, as I said, it's 1. So like so in this right triangle, of course, you have your the opposite side to the angle theta, right? So the opposite side of the angle theta would be this one. So this is the opposite side to the angle theta, right? And then you have the adjacent side, right? Because this is, here's your angle, right? This is here's your angle theta, right? So then the opposite side, right, will be, as I said, it would be this one here. This is the opposite side. Now the adjacent side to theta would be this one. This is the adjacent side. the angle theta. And then, of course, this is the hypotenuse, right? In the right triangle, so this one, the angle, the side which is opposite to the right angle, it's your hypotenuse. So this is your hypotenuse. Okay, that's the, the angle, the side opposite to the right angle. This is the side, the opposite side to the right angle. That's what I mean by the hypotenuse. Opposite side to the right angle. Right angle. Okay. Now, in the right triangle, guys, as you know, this is a Pythagorean theorem, right? So just to remind you, so let's call this the opposite side to theta. Let's call this side, this is the side, this is A, okay? This one here, this is the side B. And then, of course, they have the hypotenuse. And let's call the hypotenuse, or the length of the hypotenuse is C. Anyway, so by the Pythagorean theorem, you know that the A square, this is B, lowercase b, of course. So you know that A square plus B square, that will be the square of the length of the hypotenuse, right? This equal to C square. All right. Anyway, so now what's the sign of theta? So by definition, I'm going to define now. So by definition, so this is the definition of the sign of theta. So sine of theta, that will be the opposite side over the hypotenuse. That's the opposite side. The opposite side to the angle theta over the hypotenuse, the length of the hypotenuse. So like here, the opposite side is A, the hypotenuse is C, right? But the thing is, so in our case, the hypotenuse is the length of the hypotenuse, because this is the radius, right? This is your hypotenuse, right? This is your hypotenuse. So the length of the hypotenuse is actually equal to 1, because that's a unit circle, and the radius of the circle is 1. So the length of this hypotenuse is 1. So this is equal to 1, right? The length of the hypotenuse, it's actually 1 in this in our case, right? Because it's a unit circle, so the radius is 1. So when we have when the hypotenuse is equal to 1, sine of theta, it's just the opposite side to theta, right? So the sine of theta, that's just the opposite side to theta. Okay. Now, what about the cosine? So cosine of theta, so this is a definition. Again, so this is a definition of sine. It's the opposite side to theta over the hypotenuse. For the cosine, So cosine of theta, it's by definition is the adjacent side over the hypotenuse. By definition, so it's the adjacent side to theta over the hypotenuse. Okay, so that's the definition of cosine of theta. And of course, if the length of the hypotenuse is 1, so that's just the adjacent side to theta over 1. So that's just equal to the adjacent side of theta, right? So when the hypotenuse is 1, length of the hypotenuse is 1, then cosine of theta, it's just equal to the adjacent side. Okay. So let me just say, you can, because of this unit circle, you can think of sine and cosine as, as x and y. So when we have a unit circle, and so let me just draw again my unit circle. This is my x-axis. This is my y-axis, right? And then you have your unit circle, circle of radius 1 with the center of the origin, right? And you have some angle, theta. So let's say here's your theta. Okay. Now, if you take this point here, which represents this point here, this is the point with coordinates x and y. So here, the point here, the coordinates of this point, it's x and y, right? Because so this should be x, right? And this should be y. So if we use this coordinates x and y, then cosine of theta, cosine of theta, because, again, cosine of theta, we said it's the adjacent side over hypotenuse, right? But then we said this is a unit circle, which means that in a unit circle, the radius is 1. So the hypotenuse, this hypotenuse is 1, right? This is 1. Okay, it's a unit circle. So then this is just the adjacent side. Adjacent side to theta, right? Now, what's the length of the adjacent side? So the adjacent side in your right triangle would be this side. This is the adjacent side to theta, right? This is the adjacent side, right? To the angle theta. Now, what's the length of this adjacent side? Well, as you can see, the length is actually x, right? Because from the origin, from 0, from 0, this is your origin, right? From 0 to x, that's the length of the segment. It's or the side is just x, right? From 0 to x, it's x. So the length of this adjacent side, this is this side here, this is just x. So the length of this adjacent side is actually equal to x. So this is equal to x, right? Here's your x. And then for the sine of theta, we said it's the opposite side again over the hypotenuse. And so this is a unit circle. So the radius is 1. So the hypotenuse is 1. So it's just the opposite side of the angle theta. All right. Now, what's the opposite side of the angle theta? Well, the opposite side in our right triangle is this one here. this is the opposite side to theta, right? The angle theta is, of course, is this one right here. This is your angle theta. All right, so this would be the opposite side. This is the opposite side, right, to the angle theta. Now, what's the length of this opposite side? Or what's the height of this opposite side? As you can see, this opposite side is the same as the length of this opposite side is the same as this side right here, this one. You know, they have just the same length. Now, what's the length of this? Well, the length of this, it's just equal to, from 0 to y, it's just y, right? So the length of the opposite side is just equal to y. So this is actually equal to y. Okay. So what I'm saying here, guys, is that you can think of cosine and sine. So if you have like a unit circle, the hypotenuse is 1, then you can think of cosine as x and sine as y, right? So again, the idea is, let me just write it down here again. So the idea is, so you have a circle, unit circle, unit. You need the unit circle, of course. So the radius is 1, and you have some angle. You know, this is your, again, this is your x-axis, and this is your y-axis, and you have some angle. So let's say this is your angle theta. So this is the point xy. So this is your angle theta. Okay. Then you can think of cosine of theta as equal to x, and sine of theta is actually equal to y. Okay. And I mean, this is actually very useful. We'll see later how to use this, you know, to compute cosine and sine. All right. Is there any question, guys? So that's the definition of cosine and sine. So you have to keep in mind that is that, yes.
You're not telling us about tangent?
Oh yeah, that's what I'm gonna do next, Matthew. Yeah, absolutely, you're right. Yeah, but just for cosine and sine. So cosine is the adjacent side over the hypotenuse, and in a unit circle, you can think of cosine as just the x coordinate. Right. So this is this x coordinate. That's your cosine of theta, and the y coordinate. This your y here. That's the sine of theta. Now, yeah, absolutely. Now next, for tangent. So once we have the definition of cosine and sine, you can define the tangent of theta. You know, tangent of theta, of the angle theta, it's actually sine over cosine. Okay, and the reciprocal, cosine over sine, that's the cotangent. Okay, that's so cotangent, that's the reciprocal of tangent, so that's the cosine over sine. Okay. There's also, we can define one over cosine. That's called the secant of theta. Secant of theta, that's 1 over cosine of theta. Right. Again, this is a secant of theta. This is a cotangent. This is, of course, this is tangent. Tangent of theta, cotangent, a secant, cosecant. It's a cosecant of theta, that's 1 over sine. So cosecant of theta. Anyway, I mean, I think what we really need here is, what we really need to understand is the sine and cosine. The tangent, cotangent, etc. are just just like a consequence of the definition of a cosine and sine. Once you know how to, once you understand the cosine and sine, or how to find the cosine and sine of an angle, then tangent, cotangent, etc. is just a consequence of that. Anyway, so now let's measure, or let's compute the cosine and sine of some angles. Okay, so how do we compute? So I'm gonna compute. Let's now the goal is to compute. Let's compute cosine and sine of some angles. I'm going to show you how to do that. I mean, it's just some. It's basically using the Pythagorean theorem. But anyway, so.
Hello, Professor.
Yes. Yeah. Please.
I'm sorry.
Yeah. No problem.
I'm so confused as to why tangent equals sine over cosine.
No, it's just a definition. That's like a definition. That's like, I can call, instead of tangent, I can call something else. But sorry, but it's just the definition of tangent. That's how we define tangent.
No, I don't get it. I thought tangent is opposite over adjacent.
Yeah, that's absolutely true, because that's the same thing, because let me just erase this. That's a good point. But because I don't want to really focus on tangent, cotangent, etc. I'm going to just focus on sine and cosine. But you're right. So for example, if you take so tangent, and if you define tangent at sine over cosine, but then we said, sine is supposed to be the opposite side, right, over the hypotenuse. And cosine, it's the adjacent side over the hypotenuse, right? That's just the definition of sine and cosine. Now we can simplify this, because so this is like you divide two fractions, so you need to flip. This is the fraction in the denominator. Okay, so that's actually opposite side over hypotenuse times, and then you flip the denominator, so that's the hypotenuse over the adjacent side. And then as you can see, the hypotenuse cancel out. You have hypotenuse in the top, hypotenuse in the denominator, so your tangent is just as you said, your tangent, it's the opposite side to the adjacent side. So just as you can see, it's just a consequence, right, of the definitions. Adjacent side. Okay. I mean, that's like another way to define tangent. I can start with the definition opposite side over adjacent side, and then end up with sine over cosine. Or you start with the definition sine over cosine and end up with opposite over adjacent side. It's just like equivalent definitions, right? They're just the same thing. Make sense now?
Yeah, okay.
Okay, but anyway, there's only like one lecture left, so I'm gonna try to focus on how to compute cosine and sine, tangent, cotangent, etc. It's just probably gonna need more time, to cover everything, but I'm gonna try to focus on sine and cosine. All right, so we have like 9 minutes left. I'm going to show you an example. So how to compute this cosine and sine. So once you know how to compute cosine and sine, then you know how to compute everything else, the tangent, the cotangent, etc. But let's compute the like sine and cosine of a very simple angle, which is the angle 0. Right? Let's do an example. Theta equal to 0 degrees. Okay, or 0 radians. Okay. So what's the 0 angle? Well, you're supposed to have like initial side. This is like, this is like my initial side. Initial side, and then you're supposed to have like a terminal side, right? Terminal, right? And so the angle between the two sides from the initial to the terminal, that's your angle theta, right? Now, if your angle theta is 0, so what does it mean? Theta equal to 0 degrees. It's really 0. So the angle is 0 means that the initial side coincide with the terminal side. The initial side and terminal side are just the same, right? So when you say, so theta is 0 means initial side is the same as the terminal side, right? They coincide, right? So it's like this is my initial side, and then my terminal side is just this. It's just the same thing, right? This is my terminal side. They coincide. Right? They coincide. So that the angle theta is 0. Okay. Now I want to compute, let's say, cosine of 0. Cosine of theta, right? So this is cosine of 0 degree. Okay. And as we said, by definition, cosine it's the adjacent side over the hypotenuse, right? In your right triangle, you're supposed to have like, this is right, and this is your, this is your angle theta, and this is the adjacent side, and this is the hypotenuse. Okay. Now, if the angle is 0, right? So then, if the angle is 0, the terminal and the initial side, they're going to be equal. So this is the terminal and the initial side, they're going to coincide. So if theta is 0, so the hypotenuse is going to coincide with the adjacent side, right? Hypotenuse and adjacent side, they coincide. Okay, they're going to be the same, right? Because the angle is 0, right? We said the angle is 0, then the terminal and the initial side, they're going to coincide, right? So, yeah, so if they coincide, it means they are equal. They are the same thing. So the adjacent side is equal to the hypotenuse in this case, right? So the adjacent side or the hypotenuse is equal to your adjacent side, right? So then what will be cosine of 0 then, if the hypotenuse is the same thing as the adjacent side? Any guess?
1.
1, right? Because so what I'm saying is, this adjacent side is equal to the hypotenuse. They have the same length, right? Like, I don't know, it's like adjacent side is, or hypotenuse is 1, adjacent side is 1. They're the same. So 1 over 1 would be 1, right? So the answer is 1. Okay. Makes sense why cosine of, this is cosine of 0. I mean cosine of 0, of course. Cosine of 0 degrees. It's 1. Right? Because the adjacent side is equal to the hypotenuse. They coincide. Make sense? So if they coincide, they have the same length. If they have the same length, so then the ratio is 1, right? If you divide the adjacent side by hypotenuse, it's going to be 1. Now, for the sine, what will be the sine in this case? So remind you the definition of, so sine of theta, our theta is 0, right? It's sorry, this is 0, sine of 0 degrees. So by definition, that's supposed to be the opposite side over the hypotenuse. And again, because my angle is 0, right? So the initial, this is your initial, and this is your terminal side, they coincide, right? They are the same. So if the initial, so your initial side coincide with the terminal side, what will be the length of the opposite side? The opposite side is this one here, right? This is your opposite side. What will be the length of the opposite side if the terminal and the initial, they coincide? There will be no opposite side, right? The opposite side would be just 0. There will be no opposite side, right? So so what I'm saying is that, so if the terminal, if the terminal side, terminal and initial, one side, there will be no opposite side. Opposite side. Hey, you think of the initial side as like the adjacent side, and terminal side is like the hypotenuse, right? So there will be no opposite side. So then the length of the opposite side is 0. So in other words, the length, so length of the opposite side is going to be 0. Is the number 0. So then sine of the angle 0, well, it's the opposite side. So it's 0 over the hypotenuse, which is, of course, 0. Okay, so what we are saying is that, so the conclusion is that the sine of the angle 0 is 0. Okay. So you see how we compute the, you take your right triangle and see, you try to compute the opposite side, you compute your hypotenuse, or you compute your adjacent side, right? And then you try to find your sine and cosine. So like in this angle 0, this is like kind of a special angle, of course, angle 0. But if the angle is 0, then cosine of 0 is 1, and sine of 0 is 0. So conclusion. So next time, of course, we're gonna try to measure, compute like sine and cosine of other angles, some special angles, like a right angle will be the cosine and sine of right angle, or 30 degrees, 60 degrees, etc. So anyway, so let me just write down here. So cosine of 0 is 1, and sine of 0 is 0. So next time, guys, I'm gonna try to compute sine and cosine of other angles. All right, guys, I'm gonna stop here. Thank you for listening. And so I guess I will see you in person this Wednesday. As I said, I will post a review sheet probably tomorrow on CUNY Blackboard, and I will have a review on Monday next week. And again, this trig, this chapter 4, it's not included in the test.